Okay, so let's start off with the basics. Intermolecular forces, the definition of it is forces between different molecules. Met ander woorde, ons praat nie nou van kovalente bindings nie. Kovalente bindings is binne in 'n molekule, right? That's between the atoms within a molecule. We are talking about the molecules have already been formed, but how do the different molecules interact with one another? Are you okay? Good? Wrong book? Major panic. Saw it on her face. Okay, so for your practical next week, you are going to work with 4 different liquids. Okay? 4 verskillende soorte. The one is chloroform. Ja. So ons gaan dit nie probeer met mekaar nie, né? Ek wou dit nou nie eers gesê het nie, want ek was bang gewees iemand probeer het. That's the one they put on the rag if you want to kidnap someone. Then you put it over their face. The what stuff? No, I know. I'm looking for the notes that she gave me. It's fine. Don't worry about it. Thank you, Lydia. I'll call on you if I need it. But I don't know where I put it now, but it's fine. Okay, goed. So die een waarmee ons gaan werk is chloroform en wat julle moet weet van chloroform is die molekules is nie polêr. So the molecules are non-polar, which means between 2 chloroform molecules, what type of intermolecular force will they have? Wat se tipe intermolekulêre kragte het ons tussen 2 nie-polêre molekules? It's the induced dipole forces, but we just call them the London forces. Okay? So tussen chloroform molekules is daar London kragte. Okay. Then the next one that you're working with is acetone. Who knows what acetone is? Yeah, nail polish remover. Okay. Acetone is a polar molecule. Which means what type of intermolecular forces do they have? Dipole kragte. Onthou nou, as ek 'n houertjie acetone het, nee, if I have acetone, then all of the molecules in there are acetone. So do you agree that all of the molecules in there are polar? Okay, I'm going to repeat that. As dit 'n houertjie acetone het, nee, dan is elke acetone molekuule binne 'n houertjie mos polêr. Do you agree? So when we have a polar molecule interacting with a polar molecule, we call that a dipole force. Nee? Hierdie gaan ons nêrens sê dipool geïndiseerde dipool of sulks nie. Dit gaan net wees in my houertjie chloroform is alles mos nie polêr. Met ander woorde, tussen elke chloroform en elke ander chloroform is daar London kragte. Okay, now if I look at my beaker of acetone, all of them are polar. In other words, the only intermolecular force in action there are the dipole forces. Almal by? Okay. Ja? Hy't sterker as chloroform. Dis hoekom mense chloroform hou moet toemaak. En dis hoekom jy vinnig uitpas. Weg. Okay. Goed, en dan die volgende een wat ons gaan kyk is etanol. Wat's dit? It's an alcohol. Okay, so an alcohol group, this you guys don't need to know, but when you do organic chemistry next year, moet dit nou nie neerskryf, anders gaan julle nou net julleself verwar. Dit is die struktuurformule van 'n alcohol. Okay, now in the hydrogen bonds in your notes, it says that wherever you have this, a OH, you will have a water bond, a waterstofbinding. Nie 'n waterbinding nie, hydrogen bond forming. Okay, so a hydrogen bond is still a type of intermolecular force, but it is quite a strong intermolecular force. Okay, so hierdie gaan 'n waterstofbinding wees. Maar dit is 'n swakker voorbeeld van 'n waterstofbinding. Okay, you guys don't need to know the details of that now. And then the last one that we are going to work with is good old water. En dit gaan ook waterstofbindings hê. Maar dit gaan sterk waterstofbindings hê. Those are also polar molecules, né? Maar hulle polariteit dra nie so baie toe tot hulle intermolekulêre kragte soos wat daai waterstofbindings doen nie. Waterstofbindings is 'n baie spesiale soort intermolekulêre krag. So as ons kyk na etanol en na water, hulle is polêr, so hulle gaan dipool kragte hê. Maar in daai notas het dit ook vir julle gesê, ons kyk nie na al die kragte nie. Jy kyk na wat is die sterkste krag wat op die oomblik hier in werking is. Because if you are able to break the strongest bonds, then obviously you broke all the weaker bonds before that already, né? As jy genoeg energie ingesit het om die sterkste soort intermolekulêre krag te oorkom, dan het jy obviously al die ander ook gebreek, né? Okay. Later on we are going to do an investigation between if you have two molecules and both of them are, let's say, non-polar. Then why does the one differ from the other one? But that only comes later on. Okay. So wat julle moet weet vir nou is daai is die 4 waarmee julle gaan werk. En soos ek hulle daar neergeskryf het, is hulle in toenemende volgorde van hulle sterkte van hulle intermolekulêre kragte. So as they are written there, the intermolecular forces increases as I go down the list. Okay, met ander woorde, acetoon het sterker intermolekulêre kragte as chloroform, but it has weaker intermolecular forces than ethanol or water. Does that make sense? Okay.
So water is the strongest
Of those 4. Thank you. Het almal opgeskryf graad 11s? All of you good? Okay. So concerning the intermolecular forces, those are the stuff that you need to know there. Now what you're going to do in your practical is you are going to look at the physical properties that intermolecular forces causes, and you're going to look at 4 different ones. You're going to look at boiling point. You're going to look at evaporation. You're going to look at surface tension. And you're going to look at solvability. Okay. All 4 of those are in your notes, but you do not have to go into the major detail of it. I'm going to talk you through it, because if you understand intermolecular forces, then at least the first 3 of those should make sense, and the 4th one is a bit funky, but I'll explain it to you as well. Net nog aan. Blaai net om. Begin met digtheid, daar's boiling point and evaporation, surface tension. Ja. Go for it. Baie julle. En die solvability is in julle boeke. Ek sal nou vir julle die bladsy gee. Sterkte julle. Okay. So when we're looking at these 3, just make sure it makes sense to you. As 'n intermolekulêre krag sterker is, so if we're comparing 2 different substances and the intermolecular force of substance B is stronger than the intermolecular force of substance A, which one will have a higher boiling point? Okay, so kom ons sê ek het 2 bakkies. Hier's A, vloeistof A en vloeistof B. Ek sê nou vir jou, kom ons sê hierdie een se intermolekulêre kragte is sterker, so kom ons sê hy het waterstofbinding. And let's say this one has a weaker intermolecular force. Let's say this is, for instance, the acetone. So that only has a dipole force. Okay? Watter een van daai twee bakkies se kookpunt gaan die hoogste wees, A of B? Why A? Because it has a stronger intermolecular forces. In other words, it needs more energy to overcome the forces. Okay? Of vat hom andersom. Watse een van hulle gaan die laagste kookpunt hê? B, né? Want hy het swakker intermolekulêre kragte. Met ander woorde, dit gaan minder energie nodig hê om die kragte te oorkom. Okay guys, what are we doing when we are boiling something? You are saying if we look at water molecules, ek het hom nou verkeerd omgeteken. Okay, daar's mos nou intermolekulêre kragte tussen hulle, né? And those intermolecular forces causes them to be close enough together that they are in a liquid state. So hulle is naby genoeg aan mekaar dat hulle nou in 'n vloeistofvorm is. Wat gebeur wanneer ons kook? We are overcoming these bonds so that they can move further away from one another and evaporate and go into the gas form. Okay? So stem julle saam, hoe sterker hierdie stippellyntjie bindings is, hoe meer energie gaan dit vat om daai te doen. Met ander woorde, hoe meer hitte moet ek insit, so hoër gaan sy kookpunt wees. Okay, so now back to my list. Which one of those will have the lowest boiling point? Chloroform. And dan acetone. And then ethanol. And then water. Okay? Dis hoekom, meisies julle, as julle nail polish remover het, né? Die oomblik wat jy hom oopmaak, kan jy hom ons dadelik ruik, né? Because it's already, some of it is already in the gas form. If you leave a bucket of it outside, it will all evaporate. Terwyl as jy 'n bakkie water buite los, veral in die winter, hoe lank gaan dit vat vir dit om heeltemal te verdamp? Long time. Okay, if you put it in direct sunlight, it's another story because then it gets the energy faster. Okay, so dink aan wat beteken intermolekulêre kragte. Hoe sterker dit is, hoe meer moet ons insit om dit te oorkom. Does that make sense to you guys? Okay, now evaporation is